Electromagnetism is the study of magnetic effect of current. Electric charge can be separated into single type. For example, you can have a single negative charge or a single positive charge. Magnetic poles cannot be separated. It is not possible to have a magnetic north pole without a magnetic south pole. This is the fundamental difference between magnetism and electricity. Weak ionic current in our body that travels along the nerve can produce the magnetic effect. This forms the basis of obtaining images of different parts of body. This is done using the technique called magnetic resonance. This is done using the technique called magnetic resonance imaging. Heart and brain are two main organs where significant magnetic fields can be produced. Using MRI, doctor can diagnose the disorder of brain and heart. Ampere discovered that when a current passes through a conductor, it produces magnetic field around it. To demonstrate this, we can take a straight conductor wire and pass it vertically through a cardboard. Now connect the two ends of the conductor with the terminal of the battery so that current flows through the circuit in the clockwise direction. The lines of forces the magnetic field produced around the wire would be in the form of connectivity circles. If we place a compass needle at different points in the region of magnetic field, it will align along the direction of the magnetic field. Also, if we sprinkle some iron fillings on the cardboard around the wire, they will align themselves in the concentrated circle in the clockwise direction. If we reverse the direction of the current by reversing the terminals of the battery, the compass needle also reverses its direction. Now the magnetic field's lines will align in the anti-clockwise direction. The magnetic field produced is stronger near the current carrying conductor and weak further away from it. The direction of the magnetic field is governed by the direction of the current flowing through the conductor. A simple method of finding the direction of magnetic field around the conductor is the right hand grip rule. Grasp a wire with your right hand such that your thumb is pointed in the direction of current. Then curling fingers of your hands will point the direction of the magnetic field. A coil of wire consisting of many loops is called a sheldon. The field from each loop in a sheldon adds to the fields of the other loops and creates greater total field strength. Electric current in the sheldon will produce magnetic field which is similar to the magnetic field of the permanent bar magnet. When this current carrying sheldon is brought close to a suspended bar magnet, one end of the sheldon repels the north pole of the bar magnet. Thus, the current carrying sheldon has no north and a south pole and behaves like magnet. The type of temporary magnet which is created when current flows through by a coil is called an electromagnet. The direction of the field produced by a coil due to the flow of conventional current can be found with the help of right hand grip rule. If we grip the coil with our right hand by curling our fingers in the direction of the conventional current, our thumb will indicate the north pole of the coil. We know that the electric current produces a magnetic field similar to that of the permanent magnet. Since a magnetic field exerts force on a permanent magnet, it implies that current carrying wires should also experience a force when placed in a magnetic field. The force on a wire in a magnetic field can be demonstrated using the arrangement. A battery produces current in a wire placed inside the magnetic field of a permanent magnet. Current carrying wire produces its own magnetic field, which interacts with the field of the magnet. As a result, a force is exerted on the wire. Depending on the direction of the current, the force on with either pushes or pull it towards right or towards left. Michael Faraday discovered that the force on the wire it is a right angle to both the direction of the magnetic field and the direction of the current. The force is increased if the current in the wire is increased, strength of the magnetic field is increased, the length of the wires inside the magnetic field is increased. Faraday's description of the force on current carrying wire does not completely specify the direction of the force because of the force can be towards left or towards right. The direction of the force on a current carrying wire in a magnetic field can be found by using Fleming's left hand rules. Stretch the thumb forefingers and the middle fingers of the left hand maturely perpendicular to each other. If the forefinger points in the direction of the magnetic field, the middle finger in the direction of the current, then the thumb would indicate the direction of a force acting on the conductor. The force acting on the conductor is at right angles to both the direction of current and the magnetic field. According to Fleming's left-hand rule, if instead of a straight conductor we place a current-carrying loop inside magnetic field, the loop will rotate due to the torque acting on the coil. This is also the working principle of electric motor.